Hello, welcome. This is CH Arvind Kumar, Assistant Professor, Department of Computer Science and Engineering, Vagdevi College of Engineering. I am going to explain Network Security and Cryptography Lab. Week 10 program, write a program to implement secure hash algorithm. First we'll see what ciphers do. Ciphers provides confidentiality with the help of encryption. For example, Alice and Bob is exchanging some messages. Alice encrypt the message and encrypted message will be forwarded to Bob. If Eve try to capture the message, Eve can't see what Alice and Bob are exchanging. What cipher don't do? Suppose Alice and Bob communicating with each other. So Alice create a message M and forward it to Bob. In transmission, Eve capture the message from Alice and apply some changes on the message. That modified message is forwarded to Bob. Now Bob received the message. Bob will think the message is sent by Alice, but the message is modified by Eve. That modifications cannot identified by Bob because ciphers are only providing confidentiality. So it is not providing protection against message modification. To identify such type of modifications, we are using hash. Hash functions are providing protection against message modification and it is providing data integrity service. Hashing. A hash is a mathematical function that is represented with h, and the hash function accepts variable length block of data m as an input and produce a fixed size of hash value as an output. Suppose h is an hash function. If we input the message to hash function, it will produce hash or message digest and it is represented with h of m. Assume this is our message block with variable size m. This message will be supplied to hash function h and it will produce a fixed size hash output. If you apply any changes on the message, that will result a different hash. Hash used to detect changes to message. Cryptographic hash functions will having the following properties. It is computationally infeasible to find data mapping to specific hash. Means if you reverse the hash, it is not going to generate the plain text message. It will generate one more hash. This property is called as one-way property. And second one is computationally infeasible to find two data to same hash. Means the hash is not same for two different data units. This property is called as collision-free property. We already know that hash functions are used to identify changes on message. So we can call it as message integrity check. Remember one point, always the message integrity check must be encrypted. Now we'll try to understand how the hash functions work. Suppose there are two users, sender and receiver. Sender creates a message. That message is supplied to hash function h. This hash function h will create a hash value. That hash value and our plain text message is added. This is our plain text message and this is our hash value generated from hash function h. These two are combined and this combined message is forwarded to receiver. Receiver got the message. In that message, it will contain the message along with hash code. Now the receiver side, receiver takes only message and the message is supplied to same hash function. It will generate an hash value. The generated hash value and received hash value is compared. If the two hash values are same, the message is not modified. If the two hash values are different, generated and received hash values are different, some changes are applied on the message. Here there is no change in the message, that's why the hash values are same. The receiver will identify there is no changes applied on the message. We will see one more example. The same example, it is applied to hash function h. It will generate a hash code. That hash code and plain text message is added. This message is transferred to receiver. In middle, some hacker modify the message. Assume the hello is changed to some HELLL and the hash value is not changed because it is encrypted. The receivers apply this message to same hash function h. It will generate an hash value. After generating the hash value, generated hash value and received hash values are compared. Now see, these two hash values are different. This hash value start with AAF and this hash value start with B43. The two hash values are different. So hash not match, some modification is done on the message. In this way, the receiver identify the message is modified based on the hash value comparisons. In this way, the hash is going to work to identification of message modifications and provides data integrity service. Secure hash algorithm originally designed by NIST National Institute of Standards and Technology and NSA National Security Agents in 1993. It was revised in 1995 as Secure Hash Algorithm 1, in short SHA 1. It was designed based on MD4 with key differences, and SHA 1 produced 160-bit hash value. Later in 2002, NIST issued some revisions, added 3 additional versions of SHA: SHA 256, SHA 384, SHA 512. It was designed for compatible with increased security provided by AES cipher. Structure and detail is similar to SHA-1, hence analysis should be similar, but security levels are rather high. These are the different versions in secure hash algorithm. Every version will have some differences in output, inputs and number of steps. SHA-1 algorithm will produce 160-bit message digest and it will accept the message up to 2 to the power of 64 bits. It will divide the messages into 512-bit blocks. The word size used in SHA-1 is 32 bits. Number of steps performed in a single round is 80. Coming to next version, secure hash algorithm 224. It will produce message digest as 224 bits and it will accept the message size up to 2 to the power of 64 bits and it will divide the messages into 512-bit blocks. Word size is 32-bit and number of steps in a single round is 64. Next, secure hash algorithm 256. It will produce message digest as 256 bits, accept the message size up to 2 to the power of 64 bits. It will divide the message into 512-bit blocks. Word size is 32-bit and number of steps performed in a single round is 64. Coming to secure hash algorithm 384. It will produce message digest as 384 bits and accepts message size up to 2 to the power of 128 bit. It will divide the message into 1024-bit blocks and word size is 64 bit. Number of steps performed in a single round is 80. Coming to secure hash algorithm 512. It will produce message digest as 512 bit and it will accept the message size up to 2 to the power of 128 bits. It will divide the message into 1024-bit blocks and the word size is 64 bits. It will perform 80 steps in a single round. Secure hash algorithm is processed in 5 steps. Step 1. Append padding bits. The message is padded with some extra bits so that its length is congruent to 896 module 1024. Secure hash algorithm 512 is processed 1024 bits as an input. If we divide message into 1024 bits, the last part may or may not be fit to 1024 bits. To make that particular block as 1024 bits, we are going to add some extra dummy bits at the end of the message. That bits are 1 followed by all zeros. Even the message is in desired length, still we are going to add extra dummy bits. Step 2. Appending length. Here we are going to add 128 bit at the end of the message to represent the actual length of the message. Here the actual length of the message is L bit. To represent this length we are using this 128 bit integer. So here we are adding 128 bits. This 128 bits is not equals to 1024 bit block. To fill the remaining bits we are going to add that 896 mod 1024 bits even the message is equals to 1024 bit blocks. Step 3. Initializing hash buffer. A 512-bit buffer is used to hold intermediate and final result of the hash function. The buffer can be represented as 8 64-bit registers. These registers are initialized to the following 64 bits integers with hexadecimal values. Here we are going to use 8 64-bit registers, and these 64 registers are initialized with hexadecimal values. Combination of these 8 registers will produce a 512-bit buffer. This buffer will hold intermediate and final result of the hash function. Step 4. Processing the message in 1024-bit blocks. The entire message is divided into 1024-bit blocks, and each block is given for hash function. Hash function f performs 80 rounds. So first, the message scheduler divides the 1024-bit block into 80 different words. Each word processed and the result will be held by hash buffer. After 80 rounds, again the values are XORed with the previous round initial vector value, and finally it will produce our actual hash with size of 512 bits. Step 5. Output. After all n 1024-bit blocks have been processed, the output form nth stage is 512-bit message digest. It will produce a 512-bit message digest. This is sender program. Sender will create a message and calculate hash for that message by using secure hash algorithm. Add that hash to the message, and message along with the hash is forwarded to receiver. Receiver receives the message along with the hash code. Receiver take the message and calculate the hash for the message. Compare the two hashes, generated hash and received hash. If the two hashes are same, then receiver identifies there is no modification in message. If the two hashes are different and receiver identifies there is some modification in message. We will see the execution of this secure hash algorithm. Here we have two programs. One program is for sender, another program is for receiver. To execute these two programs, open two different terminals. In first terminal, execute receiver program. Now receiver is ready for communication. Execute sender program. Here we have to specify IP address of receiver and port number of receiver. Enter your message. It will calculate the hash code for the message and adds the hash code to the message. Message along with the hash code is sent to receiver. The receiver receives message along with hash code. To compare the hash code, take only message and supply to the same hash algorithm. Here we are using the same message, hello. It is also calculated the hash code and compare the hash code, and it is generated a message hash match, hence data is not modified during transmission. We will see with different modified input. So again execute sender program, enter your input, same it will generate message along with hash code. Receiver receives that message along with hash code. Instead of the same plain text message, change your message. Now I'm taking HELL. Just it is calculated the hash code and match the hash code, and it is giving a message hash is not matched. So your message is modified. In this way, the secure hash algorithm works. Thank you.